Hello everyone, my name is Anna, and today I'm going to talk about the blue and fin whale cold source level and propagation range in the Southern Ocean. And first, introduction. Blue whale and fin whale are the primary target of the commercial whaling industry that developed in the Southern Ocean during the 20th century. Both species are brought to near extinction before the hunt was banned, and their population recovery has been slow. So we want to know the blue whale and fin whale cold source level and propagation range at western Antarctic Peninsula, and the source level means the intensity of sound at a distance at 1 meter distance from the source. The high source level codes would be beneficial for long-range propagation. It is important for communication with conspecific. And the low population density result from commercial whaling make long-range call even more important for a species survival. And this map, it shows the area that our study take place, and the square box is our site that we deploy the instrument. And first we listen the blue whale call. Hey. And then it's fin whale call. Okay, and we stop it here. So, in this figure, the y-axis is the frequency, and the x-axis is the data that we collect, the time, the data we have collect, and the color bar is the decibel. And we can see in the figure that both blue whale and fin whale call produce the high intensity and low frequency call. And their frequency is too low that we cannot hear. So we can see here the time, their interval is at least 8 minutes, but as we just heard, they are only 30 seconds. It's because we speed up the record and to make the frequency higher than we can hear it. And this type of call is probably function for communication during mating and feeding. We use bottom-moored hydrophone to collect the sound, and the acoustic recording package to storage the sound that we collect. That's the figure here. Here is the hydrophone, and this is the ARP. And the hydrophone is suspended 10 meters above the ARP. And we use multipass arrival and time difference of arrival and hyperbolic localization to estimate the range from the source to the receiver, which is the hydrophone. And the difference between multipass arrival and time difference of arrival is the multipass arrival estimate by the co-arrival time difference to a single receiver, and the time difference of arrival estimate with the arrival time difference of the same call to multipass receiver. And after we estimate the range, we can calculate the source level. The call source level is the sum of measure receive level and calculate transmission loss. The receive level is the intensity of call measured on the receiver, and the transmission loss is the amount of intensity decreased relative to its source level. And in this figure is the blue whale call, and there are 3 segments. And here is the 9-second long 27 Hz tone. And here is the first downswept and with 1 second downswept to 90 Hz. And here is the long-lasting downswept to 18 Hz. We use this part to estimate the receive level and transmission loss. And the fin whale, their call is short downswept from 28 to 15 Hz. We use this part to estimate the receive level and transmission loss. And in the blue whale, there are 84 individual calls we collect, and the calls are sequential lasted at least 30 minutes, which that is possible to estimate whether this call is coming from the same animal. And owing to the ARP array geometry, calls from the same blue whale could be heard on 3 instruments that make us collect the receive level with 252 is the 3 times of 284. And this is the transmission loss. The black line is the empirically transmission loss, and dashed line, green line is the theoretical transmission loss. In the fin whale, we collect the 83 fin whale calls. The longest period was 21 minutes. And clear call occurred only every 3 or 4 minutes, which is not impossible to estimate whether, to determine whether this call is come from the same animal. So the variation of receive level is not produced of fin whales. And the maximum range to calling fin whale is determined 15.6 kilometers. And this figure is the source level distribution with blue whale calls. And this is the source level distribution with fin whale calls. And the low population density of these 2 species in the Southern Ocean, high source level call would be beneficial for long-range propagation and successful communication with conspecific. From the source level we estimate the theoretical maximum range of about 1,300 kilometers over which this call could be detected by conspecific. However, this theoretical range is shorted by the real-life constraint imposed on call propagation by the change in the physical properties such as sound speed profile at the front of the Antarctic circumpolar current. And the correlation worth investigating is possible change in the source level during period of high acoustic noise. Fin whale create a noise band in the 15 to 28 Hertz band during high acoustic noise present. And if blue whale, for example, use the call for communication with conspecific, they would have to overcome the noise by increase their source level or changing their call frequency, and which is not impossible in this study due to the low ambient noise in the Antarctic. Thanks for listening.
You spoke through your discussion, and may I have some conclusion, please?
Conclusion.
Do you want her to conclude now?
Okay. And he wants to know the conclusion of this paper. And you can see the source level, their source level are really high. And this make their propagation range can be 1,300 kilometer, and even more higher, even more longer.
Can you explain again what is source level?
Repeat the question.
And she wants to know what is the source level. Source level is the intensity at 1 meter away from the source. Then the receiver get the sounds, the intensity of sounds, will measure it.
In your result, thin wheel, the left figure, why the source level between 182 to 184 didn't have number of blue whale.
Oh.
What's her question?
She wants to know why 182 and 184, the fin whale have source level and the blue whale don't have. I don't know. Maybe it's just not collected around this range.
Okay.
How to separate the noise, the background noise and the wheel sound?
What's his question?
He wants to know how we separate the noise and the voice we want. We use fast Fourier analyze. We use it Fourier transform time domain to frequency domain. Then we can pick the frequency we want and throughout the frequency that we don't want.
Please repeat the purpose.
So he wants to know the purpose. The purpose is the fin whale and blue whale of the Western Antarctic Peninsula is being commercial whaling, and they're almost extinction. So we want to know their call range, how long their call can be detected by the other species, by other conspecific. And this call is probably function during mating and looking for food. So if they can hear each other from the long range, they can meet each other in maybe mating or can find food at that place.
So you talk about you speed up the whale sounds, and what if happens like if you play it in a normal pace?
You cannot hear the call because it's under 20 hertz.
You in your discussion you say fin whales have a noise band. Do you put the noise band on your result or not?
What's his question?
You want to know if I put the fin whale noise band in the result, and there is not because it's the investigation that we maybe can do, but it's not collected in in Western Antarctic Peninsula because the noise over of here is really low. There is few animal can make voice, and human-made noise is almost none. So
how do you know this noise band?
From other place like Atlantic Ocean.
I want to know the in result, the slope and the dot mean and represent what?
You mean this figure? This dot is the receive level that we collect, because there are 3 instruments can collect the blue whale calls, so we can measure the 3 value of receive level. So, and then we will use the average of these 3 values to calculate the source level, and this line is the best fit line through the data, and here shows the negative relation with range and receive level. First of all, since we are in these slides, I think the results figures, how many are there? Here, in this figure, you have used the audio that you played to explain its axis, which is good. However, when it came to this figure and that figure, you already forgot to introduce them, and their meaning are not self-explanatory. That means not everyone can look at this figure and know what it means. Especially when you were introducing the slides, the first thing you did was always to read the sentence here. But a better way, I think the sentence was a little bit like a summarizing these figures. So it's better to show us or introduce the figure first. What's the x-axis, y-axis, what are the dots here, and what is this line? Then you conclude your figure with the sentence. That would be a better sequence of presentation. And the same for this figure. You also forgot what is to tell us what's the x-axis and what's the y-axis. And I actually don't even remember during your talk, did you say this is the blue whale and this is the fin whale? I forgot. Maybe you said. But because here you said fin whale, I was thinking, are you inferring that both of them are fin whales? But this is not right. This is blue whale. This is fin whale. So this should be, maybe you type blue whale, fin whale. It's easier for us to say, okay, what's the difference? And okay, and then this is very, very difficult to follow. So as I said so many times, maybe 25 times already, please reduce the word contents, or you move. If this discussion point is related to a specific figure, you move this point below that figure, so we know that's your interpretation. Or if this is not related to a specific result figure, you can add some figure below. Like a good example would be Jason's talk today. So he's added some additional figure he found from the internet, so we have a better understanding. Human beings, they are visual animals, right? So it's easier for us to look at the figure and get the key points. And slides like this is extremely difficult to understand. I would say we just go to read the paper, yeah. And then, as Nathan's question, is a little bit like a drop stop for your talk. Like you gave us a lot of discussion and then stop. So it's better to wrap up your study by giving a conclusion. And then these slides, this figure from the paper, I think it should be presented next time in your method. Here, not this one. Here you were having long lines discussing all this approach, how to identify the distance. But in the original paper, there was this nice reflection figure describing the principle. So it's good to add that figure into your talk. And since it's related to the animal acoustic by acoustic, it's good to see that she added audios of human whale calls. That's really helpful. And lastly, this is actually not purpose. If you read the text more clearly, it's a little bit like introduction or what whales use their calls to achieve. So for purpose, it should be, what do you want to achieve in this study? And in your study, you're not talking about mating behavior, right? You're talking about their sound characteristic and the distance. So next time, please revise the purpose. And also use this, I will also highlight that please use larger font whenever possible. Okay, let's thank Anna.